Good afternoon, everyone. It is 1 o'clock, and thank you for being here to the Trusted AI Scale Ask Me Anything. We are so excited to have you all here joining us today for our Trusted AI at Scale Ask Me Anything event. I'm Denise Lee, AFRL Information Director at SBIR STTR Program Manager. I'll be your moderator for today's AMA. Today, we are here to talk about the 6 SBIR and 2 STTR topics currently in pre-release and details regarding these Trusted AI system funding opportunities. We have an incredible group of knowledgeable presenters here to provide a variant of insight for the topics also located on the DSIP portal. Some are authors and some are co-authors of the topic. Others are evaluators for submissions, AI experts, and contracting officials within the Air Force. There has been already a tremendous response to our pre-release, and today we're here to answer your questions live until 3 p.m. Before we get our topics and questions, however, let me first introduce you to our esteemed guest, Dr. Bryant Wysocki. Thank you, Bryant. We're so happy to have you here today.
Thank you, Denise. You're way too kind. So welcome today to the Trusted AI at Scale Ask Me Anything session. I'm Bryant Wysocki. I'm the Air Force Tech Advisor for C4I and Cyber. So the U.S. Department of Defense protects our nation by deterring war and winning the nation's war when deterrence fails. So in supporting this mission, we leverage science and technology to build our advantage, to increase our deterrence and protect national interests. Artificial intelligence is a critical aspect of this national science and technology strategy. AI research continues to push capabilities at a rapid pace, with the increasing need to design systems that are safe, robust, generalizable, and trustworthy. AI systems that learn and adapt have great potential, but they are difficult to fit into traditional test and evaluation processes. Historically, and still typically today, products and systems are rigorously tested prior to release, with strict configuration management so that engineers well understand how a particular product will behave in its operational environment. And this is done prior to deployment as part of the test and evaluation, validation, and verification process. Additionally, any changes to a fielded system require retesting. These test engineers develop meticulous plans and experimentations to explore failure mechanisms and systems behaviors. This is how we best ensure the safe, predictable operation of a given product. But how do we test and improve systems that evolve code over time? Systems with actions that are not always fully understood, and systems that alter the behavior based on external stimuli, on learning and training. This is the state of artificial intelligence. And traditional test and evaluation techniques are really not sufficient to provide assurance under such conditions. As a result of this, agencies lack common metrics to assess trustworthiness and intended performance, so that an entirely new type of T&E is needed. And as a recent National Security Commission on AI final report states, this trustworthy AI, this test and evaluation is a priority task and a very challenging one. So explainable AI, trustworthy AI, supervised learning, right? Human-machine teaming, and emergent cooperative behaviors. These are all topics on the forefront of artificial intelligence. So the DoD has taken significant actions to realize the benefits of AI. Some of our goals are in delivering AI-enabled capabilities while scaling AI's impact across the services to the joint community. We are cultivating a leading AI workforce, and we engage with commercial, academic, and international allies and partners in this effort, as we strive to lead the world in military ethics and AI safety. To do this, we are developing AI principles for defense. We are investing research, as you see today, in resilient, robust, reliable, and secure applications. We are working to better understand and explain AI actions and decision-making. And we advocate for a global set of military AI guidelines. The DoD is using AI to increase operational effectiveness, to strengthen our deterrence, and reduce the risk of collateral damage. So we're all aware that artificial intelligence is revolutionary on a global scale, and its responsible implementation is an obligation that we all share. Today's Trusted AI at Scale Ask Me Anything session is just one part of a much larger government initiative to ensure the thoughtful, responsible, and human-centered adoption of AI to strengthen our national security and transform the speed and agility of our operations. So I want to thank everybody for attending today. This is an exciting topic, and we're really looking forward to unveiling these technical challenges. And we're glad to help assemble an ecosystem where together we tackle some of the nation's most important science and technology challenges. So again, thank you for your attendance. Denise, back to you.
Thank you, Dr. Wysocki. Actually, let's talk about the current SBIR topics that are out there and what are the requirements that we have. So the SBIR topics are direct to phase 2. Requirements of a phase 1 must be met in order to submit a proposal and qualify for the direct to phase 2. Currently, the SBIR funding is $1 million per award with a period of performance of 18 months. STTR is $156K per award with a period of performance of 5 months. And do remember that the actual pitch day is a virtual event. Due to the current COVID restrictions, we are not allowed to go into a live event, which is very sad, but true. Today, let's talk about the proposals and the process. Process of the proposals will be evaluated. The most promising proposals will move forward to the briefing stage. Briefers will present the slides submitted in the original proposal without any alteration to that without any alteration to the slides to a virtual evaluation team. Select awardees will progress to the contracting negotiations. So with that, let's talk about, it's time to shift over and open up our meeting to our outstanding experts in the AI topics. We have gathered an impressive number of individuals across AFRL directorates and PEOs to answer your questions live. Each presenter will provide an overview of their topic before we open the floor to questions. We encourage you to submit any questions you have in the Q&A panel area. To best answer them, we please be sure to include the topic and/or topic number your question is addressing. As we progress this afternoon, our team will be collecting your questions from the Q&A panel. And in order for our team to receive your question, please be sure to include it under all panelists and not directed to any particular speaker. It is my pleasure to first introduce you to Dr. Alvaro Velasquez from AFRL. Alvaro will be presenting on 2 of our SBIR and 1 of our STTR topics. To begin, he will be presenting on the topic of transfer learning of control policies, which is the SBIR D001. Welcome, Alvaro, and thank you for taking the time to speak with us today.
Yes, thank you, Denise. Thank you, Dr. Wysocki. I hope I am audible and visible to everyone. So my topic, this first one, is on transfer learning for control policies. The high-level idea being that we want to learn some decision-making information over a surrogate M&S environment and then transfer this information to a target environment. Now, why would we want to do this? Transfer learning has a very long history, in particular within the fields of computer vision and natural language processing, and it's allowed the mitigation of data requirements when you don't have that much data. So, for example, in computer vision, let's say for Air Force purposes, we want to detect some kind of aircraft. Perhaps it's a sensitive aircraft. Perhaps we only have 100 labeled instances, right? This is all hypothetical. Clearly, you would not train a classifier over 100 instances and hope that you get a high confidence output. It's just not enough data. But what you can do is you can train over something like ImageNet, train over that tens of thousands of images, learn the underlying features that constitute the various relevant outcomes. In the case of aircraft, these would be the wings, windshield, etc. And then you can fine-tune the parameters of your learning model over your 100 instances of this aircraft. So that's an example of transfer learning and how it can significantly mitigate data requirements. We've also seen this in NLP. Since about 2017, the NLP community has really blown up. You can take these sophisticated language models, usually some kind of attention network or a transformer, long short-term memory network, something like this. And you can train it over Wikipedia, over speeches, over TV shows, whatever you want, right? And it'll essentially learn a prior over what the English language is. And then you can fine-tune it for your data limited scenario, maybe something like tactical chat for Air Force purposes, right? Now, why does that not suffice for decision making? It doesn't suffice for two reasons. In autonomous decision making, where you want to derive a control policy, you have an agent acting in an environment. What the agent has a set of actions enabled to it, which it can execute, right? An aircraft can shoot down an enemy aircraft, fly in some direction, etc. There's some set of actions. And when the agent executes these actions, it is essentially affecting the future observed probability distribution of future states. This is a phenomenon that you don't really encounter in computer vision and natural language processing, because in these decision-making problems, you have a closed system. It's a feedback loop. So as the agents take actions, they're affecting the future things that they may observe. So it's a temporally extended problem. It's not an immediate problem like CV and NLP. Furthermore, the agent is reasoning about a long-term objective, right? This might be, for example, suppression of enemy air defenses or some such relevant Air Force problem. So it doesn't take just one action to determine whether what you did was good or not. This is a significant contrast to computer vision. So these two challenges have to be mitigated, and that's sort of what the crux of this topic is about. The crux of this topic is, can we get a surrogate simulation environment, learn a decision-making policy, and transfer that learned decision-making information to a target M&S environment? Now, what might a target M&S environment look like? In an ideal world, this would be something like AFSIM or AWSIM, right? These are our Air Force M&S tools. So in AFSIM, you can execute a COA on the order of minutes for a medium to large campaign. In AWSIM, you can execute an air tasking order in about 2 hours, okay? So these are our high fidelity, tried and true M&S environments, but they're far too slow to be able to adopt where the state of the art is in decision making. When you look at things like the AlphaGo system that beat the World Go champion, that took over 30 million games to achieve its performance. Clearly, we're not going to run AFSIM for tens or hundreds of millions of minutes, much less AWSIM for tens of millions of hours. That makes no sense. You look at OpenAI 5 system that played Dota 2 at a world champion level, very relevant game to the Air Force, multi-agent, 2 teams, real-time strategy. We would love to adopt this system, but it took over 45,000 years worth of data to train. Again, we're not going to be able to pull this off with AFSIM or AWSIM. So the idea is that we can define our own, for example, OpenAI gym environments. These run very, very quickly in under 1 second. Perhaps we can run these for tens of millions of instances and then transfer what was learned within these OpenAI gym or PIA C2 or whatever have you, and transfer that learned information to our higher fidelity environments such as AFSM and AWESOM. So that's the motivation behind the problem. I know I only have 5 minutes to talk, but during the Q&A, please feel free to ask me what evaluation metrics might look like, what similarity metrics to determine the transferability between two environments might look like, and so on and so on. I'll hand it back to Denise now.
Dr. Velasquez, thank you so much for your time. And that was a great overview. Next, we have Mr. Stephen Drager from AFRL, who will be presenting the topic of assurance of trusted AI/ML systems, which is the SBIR D002. Stephen, welcome and thank you for presenting on this topic.
Good afternoon. So just a quick intro. I'm in the Trusted Systems branch of the Information Directorate, and we've been working for a number of years on complex software-intensive systems, assuring their predictability, and that includes dealing with behavior. And so what we've been working towards is a model-based cyber and software engineering approach to create a more automated development lifecycle where we're starting with the requirements and specifications and use architectural models to design, analyze, generate the code, generate assurance evidence for the specific system under test, all in the guise of the digital engineering strategy that the DoDs produce, so that we've got our systems reliable, safe, and secure from a software perspective. So from the trusted AI ML part, we're looking, a key part of this topic is how we take that trust and use its ability to impart and assess classical security attributes of our system. So we need assurance in our AI-based software, and it has to be weighted against the up-and-coming rapid development pipelines that we're producing our systems under: continuous integration, continuous development, and DevSecOps approaches. The issue or the concern that we need to overcome is that these pipelines often rely on security measures which are external to that pipeline, such as code design reviews, and they may contain systematic failures and certainly lack the engineering rigor that we need for this predictability of our systems and providing proof to verification, validation, and certifying officials. So we're looking to rectify these requirements with comprehensive security engineering approaches, enabling trust throughout the systematic addressing of the vulnerabilities that might arise in our IA system design and development and test operations. So our objective is, and I'm not going to read the objective word for word, but highlight some of the parts that we believe are key to the topic, and that is the exploration of the tools, techniques, and methods to help support the development of our trusted AI systems, and in particular at the speed and the scale that the modern development pipelines require. We're not working with waterfall development anymore. We're working with continuous processes, and so solutions that we've used to provide proof and evidence and assurance of our systems, such as formal methods, we need to accelerate so that they're within those scale and speeds required for the development processes. There's a list of certain key aspects of the topic. We're not looking, a solid proposal does not have to address every single one of those aspects, but it's a large challenge problem area, and so but you need to address at least one of those. And then the solution should provide either an integrated process, be able to integrate into a Devsecops process, or standalone technology, which would be used in the Devsecops process for the security engineering of our AI systems. There is no requirements for the use of government material, equipment, data. It's very much a dual-use technology. For instance, we have efforts going on with Boeing, who is working with FAA and looking at how the evidence can be provided into system to make sure that those systems are flight worthy across the national aerospace. With that, I'll turn it back over to Denise.
Thanks, Mr. Drager. That was a really great, insightful background on your topic. So appreciate your time on that. Next up on the topic of applications of AI and ML, SBIR D003, we have Captain Matt Rudin from the PEO Digital. Captain Rudin, thank you for being here today and welcome.
Good afternoon, ladies and gentlemen. I'm Captain Matt Rudin, and I'm the topic author for SBIR D003, Applications of AI ML. I'm the Chief Innovation Officer for the Digital Directorate, which is located at Hanscom Air Force Base, Massachusetts. Our directorate has mission areas in network communications, anti-drone technology, digital engineering, and software development. Although I'm listed as the topic author, I must admit that I rely on an esteemed group of experts who wrote the emphasis areas for this topic, and they are on the line with me today. I'll be reaching out to them during the Q&A portion to help answer your questions. The Digital Directorate and C3INN Directorate are interested in AI/ML to advance technology in the following emphasis areas. From our Aerospace Management Systems Division, the first emphasis area is real-time operational AI. We're interested in exploring using intelligent systems to assist and reduce air traffic control workload, potentially reducing safe aircraft separation to increase sorties or reduce fuel consumption while maintaining or improving safety of flight, analyze flight paths, traffic volume, controller workload, range scheduling, optimize routes, or for dynamic resource allocation and system optimization. We'll also want to consider precision approach radars to provide voice guidance for precision approach landings in agile combat operations without dedicated human controllers or modification of aircraft avionics. From our C2ISR division, the second emphasis area is putting the sec in Devsecops for machine learning. We're seeking to develop a static code analysis tool for neural network serialized graphs, open neural network exchange, TensorFlow saved model format, etc., in order to automatically identify vulnerabilities and ensure that new and retrained neural networks are secure to mitigate the risk of malicious neural networks within operations. From our AWACS division, the third emphasis area is automate routine battle management functions. We're looking to explore deploying AI to further automate many of the air battle managers' functions, allowing for air battle managers to concentrate on functions that truly require humans in the loop. From our Force Protection division, the fourth emphasis area is computer vision threat detection. We're seeking AI/ML-based computer vision technology to perform real-time threat detection and classification using full motion video provided by CCTV and electro-optical infrared sensors. We're also looking for applications to reduce current system false nuisance alarm rate. And finally, from the C3INN Directorate, the fifth emphasis area is AI for tactical cognitive radios. Optimize rogue RF signal detection, classification, and response to detection and jamming signals in space can be significantly enhanced with a trained neural network using machine learning and AI techniques. Applying AI techniques to a deployed compact system in a field environment are expected to yield real-time response and collection of signals intelligence without the need for significant offline processing and reduced power requirements. That's all I have to share. Back to you, Denise.
Captain Rudin, that was excellent. Thank you again to you and your team for being, with us in the collaboration. So I'm going to welcome back Dr. Velasquez. This time he will be discussing the topic of explainable decision making, which is the SBIR D004. Alvaro, over to you again.
Yes, hello again. So yeah, this topic, as the name suggests, it's fully self-explanatory. We're seeking explainable AI solutions for decision-making problems. So explainable AI has really blown up in the past few years. We've seen, for example, DARPA's XAI program. A lot of good work has come out of that. DARPA's GUARD program, guarding AI against robustness deception. I know there's some explainable work being done there. The Assured Autonomy program, I believe, has some as well. And IBM has a toolbox for, I believe, explainable and robust AI. And if you attend conferences, you'll see that explainable AI is a sort of a very hot field right now. But a lot of the results in explainable AI, the vast majority have been limited to your standard classification problems. That is to say, if in computer vision, if you want to detect some underlying phenomenon in an image, maybe you're trying to detect, again, an aircraft, right? And you have a trained classifier, an explainable AI solution might tell you, well, this is why we thought it was an aircraft. And it might highlight the wings, the windshield, etc. And there's a lot of good work being done there. We've seen a lot of things, for example, with attributions that look at how each feature or each individual pixel changes the prediction outcome of a learning model and then emphasizes those as part of the explanation. We've seen class activation maps. We've seen all kinds of things. Very, very good work being done in this space. But again, and I hope I'm not putting too fine a point on this, the decision-making problem is different than the classification problem. The classification problem is an immediate result. You feed your input, you get your output, you're done. It's not a feedback loop system. In the decision-making setting, you have an agent acting in an environment, and the agent is essentially changing the state of the environment it interacts in. So for example, if an agent chooses to shoot down an enemy aircraft, well, you're not going to see that enemy aircraft again, right? So the actions that the agent takes change the data distribution of what you will observe in the future. I mentioned this during the transfer learning problem. And again, the agent is reasoning over a temporally extended objective. It takes many actions for it to accomplish its mission, unlike the classification setting where everything is just immediate. So this again brings in some challenges. And let me say it took some. Yeah, so we would like to address these two challenges when it comes to explainable AI by deriving some kind of explanation. This can be in the form of, for example, first order logic. This can be in the form of even a computational language, right? We know that, for example, there's a Chomsky hierarchy of languages where you can give an explanation as an automaton, which is complete for what is known as the regular language. You can give an explanation as a push-down automaton, which can recognize any context-free language, and so on and so forth. The point is that we should be able to yield a human interpretable explanation of behavior for decision-making agents. It is worth noting that the solutions that currently exist for classification can still be adopted and extended for the decision-making setting. But classification solutions alone will not likely suffice for decision making because, again, you have to take into account these temporally extended objectives. Now, it is also important that we know how to bound the confidence in an explanation. So the National Institute of, is it Science and Technology, Standards and Technology, NIST, they released within the past year a document on the 4 principles of explainable AI. And bounding the confidence of an explanation and making sure that an agent does not act unless it has a certain confidence level in what it's doing, those are 2 of the 4 principles. So it is important under this topic that you not only derive an explainable decision-making solution, but that you explore how one might compute a level of confidence or uncertainty in the explanation. There's some exciting work being done along those lines in the area of PAC learning, probably approximately correct learning, where you can study things like how many samples you need to achieve a certain confidence bound in an explanation. So there's a lot of exciting work to leverage here. As far as the evaluation, how do you know you have a good explanation? There are a few things that one can do. So for example, if you decide that you want your explanation to take the form of a regular language, then you might present an explanation as an automaton, right? A finite state transition system with some accepting states that define when you've achieved your mission. Now, you can have a ground truth version of that automaton. You can then compute the explanation as an automaton and compute the difference between these 2, the ground truth explanation and the derived explanation. There are all kinds of, for example, graph metrics that one might use to determine these evaluations. So with that, I'll hand it back to Denise.
Thank you once again, Dr. Velasquez. Before we continue with our presenters, I just wanted to remind our viewers that our topic presenters and their contributors will be answering questions at the end of our topic introductions. Please continue to add your questions to the Q&A panel and reference the name and or number of the topics as well. If you've already put this in there, or if you've asked a question and you didn't reference that, can you please make sure that you follow back with that, and that way our team can cover that as well. Next, we have Dr. Chris Myers from AFRL. He will be presenting on the behavioral models, methods, and metrics for trust establishment, maintenance and repair, and human-machine co-training, which is our SBIR D005. Chris, welcome and thank you for joining us.
Thanks, Denise. I'm a senior cognitive scientist in the Cognitive Models branch of the Airman Systems Directorate, and this topic was a collaboration between AFOSR RTA and the Airman Systems Directorate, co-authored by Drs. Laura Steckman and Peter Friedland at AFOSR. And so today, intelligent systems meant to operate with human partners are typically trained independent of its intended teammates. So take autonomous cars, for example. They're trained on what to observe and how to behave given those observations independent of a human driver. That is, neither the human nor the machine learn each other's driving styles, preferences, weaknesses, or strengths while being trained in their respective tasks, and then are expected to be brought back together and perform optimally together. And of course, this lack of acquisition or new knowledge continues during performance in the wild. So the objective of this particular topic is to explore simultaneously training humans and machine partners to facilitate the establishment of trust, its maintenance, and its repair when failures occur through the development of artificially intelligent systems capable of co-training with human team members. And so by co-training, I mean at least one of the partnering systems, there has to be at least one human partnering with an intelligent system throughout the individual and team skill acquisition processes. Exposing team members to each other's strengths, weaknesses, communication styles, as well as how to maintain trust and repair it when needed. And so to achieve this goal, developers will likely need to provide intelligent systems with some human-like cognitive capacities, although, I'm happy to be proven wrong. So provide some type of human-like cognitive capacities to facilitate the dynamic processes associated with the establishment, maintenance, and repair of trust, such as, but not limited to, human skill acquisition rates, so learning capabilities within the intelligent system that approximate humans so that they can stay approximately on the same page as they're acquiring skill in their requisite roles. The acquisition of mutual knowledge, beliefs, and assumptions about the task to facilitate efficient communication, and this is often referred to as common ground, as well as situation awareness, among other potential cognitive capacities as well. Now, there are 3 critical facets associated with achieving the goal of trust establishment, maintenance, and repair in human-machine code training. And those include, first, of course, the development of an intelligent system, as well as the ability to evaluate the intelligent system. 2 is co-training methodologies. How do you integrate a machine and a machine learning system, not machine learning in the sense of bottom-up vector-based machine learning, but a machine or an intelligent system, let's put it that way, an intelligent system and a human together that can train as one. So what methodologies are appropriate or needed or beneficial to achieving that? And then 3, metrics that capture the dynamics of skill acquisition, trust, establishment, maintenance, and repair within a team or co-learning paradigm. And so the specified and expected outcome from awarded proposals would be a demonstrable prototype system. Specifically, the proposed solutions should present some examples of failures and successes in human-machine trust through co-training. A successfully completed phase 2 project will be capable of demonstrating human-machine co-training effects on trust and skill acquisition. This is all that I have, and if you have any questions, I'm happy to entertain them today. And if you'd like to set up an opportunity to meet and discuss this, please feel free to reach out to me via email and we can set something up. Thanks.
Excellent. Thanks, Dr. Myers. You did a great job in the presentation and the explanation of what the topic is all about. Next, we have Dr. Joe Lyons from AFRL to talk on life cycle approaches to transparency in human autonomy, teams for generating common ground and trust calibration. SBIR D006. Joe, thank you for being here today and give us a summary on this topic. Appreciate it. Over to you.
Yeah, thanks, Denise. Appreciate the intro. So I'm Joseph Lyons. I'm a principal psychologist with the Airman Systems Directorate, the same organization that Dr. Myers just mentioned. And so I'm going to be talking to you today about the Trusted AI at Scale topic for life cycle approaches for transparency. And so let me begin by saying, or asking the question really, what is transparency? When I view transparency as a set of methods to establish shared awareness and shared intent between humans and intelligent machines. Now, a key word in there is methods, plural, right? However, oftentimes in the literature on this topic, and I'm guilty of this as well as are many folks in academia, right? We tend to adopt one approach for transparency. We apply it to a particular context and we test it out. We see, is that effective in that particular domain? And so for this topic, I'd like to move beyond that single approach to look at multiple approaches. So again, transparency, this is the idea of shared awareness and shared intent. There are a couple models of transparency that exist in the literature, one of which is the model situation awareness-based transparency put forward by Jessie Chen and her colleagues. And this adopts the view that transparency can be awareness, understanding, and projection of transparency. There's also the model of human-robot interaction transparency that I put forward back in 2013. And this model views transparency across a variety of approaches, ranging from the purpose, the task-related approaches, the analytics, and the social intent of the situation. Because again, from my perspective, I think that the social intent of a machine becomes more important the more authority and the more capability that machine might possess. So some typical approaches for transparency might involve decision rationale. So if you're working with a decision aid, why does it give you a certain recommendation, highlighting some of those criteria that it used in making that recommendation? Looking at approaches for state awareness and projection of behavior for agents in particular scenarios. Lots of these have been UAS control sorts of scenarios. And as Dr. Velasquez mentioned earlier, explanation can actually be a really rich form of transparency because it helps us understand the why. Why did a machine make a decision? Why is it doing certain things? That's really important for us as humans. And so what I'd like to do, and granted this is difficult in a 5-minute block, but I'd like to talk about one particular use case. And this use case is going to be familiar to all of us, and it's going to be non-military. And I only illustrate this for the fact that it's a non-military use case, so it's not kind of leading you down a particular path. I will note that the solutions that we're looking for are going to want to be military oriented, but I provide this use case to provide an example. So let's provide the use case of autonomous cars, right? We're all familiar with the idea of autonomous vehicles and technologies that might promote more autonomy in those situations. Now, transparency approaches here could be highly varied. Imagine that you're a designer of the new autonomous car. How do you design it with the right hooks for it to inject transparency for different perspectives? So the design approach is a perspective. What if you were a tester of this technology and you needed to show that the technology adhered to a certain set of principles in both nominal and off-nominal conditions? Here it's kind of more about the experience in designing this scenario, which is really interesting from a transparency perspective. It can also be about intent. How do you design it to show that it's actually providing a certain level of protection, for instance, in off-nominal conditions? Again, this is kind of more about the scenario design. If you were using any kind of machine learning approaches, being able to categorize the data, the machine learning data, using metadata to tag it for potential categorization of coverage, of potential bias, really trying to look at the learning affordances that it's been trained against. You might consider it an operational display for an actual driver, right? So we've all driven cars, and I would speculate that the information needs we might have had the first time we were in a car were probably different than the information needs we had as we're drivers with more experience now. So certainly the whole experience issue, novice versus expert, is another approach to consider. Understanding operator experiences, what we might need from a tester perspective might be different than what an operator, an actual driver might need from that perspective to really understand the full range of capabilities, right? And finally, let me say, the ideas of conveying transparency is not just about a driver, but also pedestrians, other drivers on the road, these other perspectives we can bring into play for this particular topic. And I believe I'm out of time, so I'm going to turn it back over to Denise. Thank you.
Thank you, Dr. Lyons. Really great to have all of your background on this. This is really great. So we're going to kind of turn the tables now. So we have the 6 SBIR topics. You have the summaries on what we just did. We're going to go over into the STTR part. So once again, I'd like to welcome back Dr. Velasquez. This time he will be discussing the topic of hierarchical, heterogeneous planning and scheduling, which is STTR T001. Take a moment and talk on this topic, Alvaro, please. Thanks.
Of course, I'd be happy to. So under this topic of hierarchical and heterogeneous planning and scheduling, all we're really looking for are mathematically principled models and solutions to relevant Air Force problems. There are many reasons why we would want to do this, but I guess first and foremost, it's my opinion that we have a communication problem within the Air Force. So when you get 2 people and they're talking about the same Air Force problem, let's say it's JADC2, Joint All-Domain Command and Control, I often suspect that these 2 people are not talking about exactly the same thing, right? These sort of problems are not precisely defined, and they're certainly not defined in mathematically precise terms in particular. So why is it important to do this? Because if I give you a mathematical model, you don't have to know anything about JADC2, right? Or whichever Air Force problem we're talking about. If I give you the math model, the math speaks for itself. For example, if you take an academic who knows nothing about the Air Force and you give them the mathematical formulation for dynamic joint targeting problem, they don't even have to know it's dynamic joint targeting, right? The math tells you everything you need to know. So I'll give you one example of some ongoing work we have. Take, for example, the maximum on-ground parking problem. It's a well-known problem for air mobility. It can simply be stated as you have a set of aircraft and you have a set of airfields, and you want to assign the aircraft to the airfields where they're going to get processed and refueled, and they'll go on their mission, such that you use the minimum number of airfields, or such that you maximize the packing density of the airfields. Turns out to be a very important problem. We've been told this by our Indo-PACOM stakeholders. I don't know that I don't have an operational background, so I have to take his word for it. But what can we do when we're presented with this maximum on-ground problem? First thing we can do is we can try to abstract it into a mathematical formulation, right? We can vectorize the dimensions of the aircraft based on wingspan, for example. We can vectorize the capacities of the airfields. We can present this as a graph, a bipartite graph in particular, where you have all the aircraft on one side, all the airfields on another side, the connectivity structure of which aircraft can be assigned to which airfields. And as you develop this abstraction, first of all, if you present this to anyone with some modicum of mathematical background, they'll understand what you're talking about. But more importantly, the more you look at this abstraction, the more you realize that it resembles some very famous problems from the operations research and related communities. In particular, this is almost identical to what is known as the bin packing problem. So essentially, you can now reduce maximum on-ground parking, this very important, relevant Air Force problem, to this other academic problem that has been studied for over 40 years. Now, why do we care about that? Because this problem that's been studied for over 40 years, we have very good solutions for it. We know the complexity of it. In particular, we know that even though it sounds simple, it's actually a very complex problem. The algorithms to solve it optimally run very, very slowly. But that might not matter, because if you have only, say, 200 aircraft, 20 airfields, you can still solve it in a few seconds. If scalability becomes a problem, we know that bin packing has very good approximation algorithms. We know heuristics. We know all kinds of things. So now all of this language, all of these results that have been amassed over the last 40 years, all of a sudden we can now apply these directly to maximum on-ground. Now, I suspect maximum on-ground parking is not the only problem that is amenable to such mathematical formulations and reducibility to existing art. There are all kinds of neat problems that have been studied by the operations research community, by the combinatorial optimization community, by the complexity theory community. And I suspect that we can adopt all of those results that have been amassed for the better part of a century and apply them to our own Air Force problems. Now, what is unique about this topic in particular is that not only do we want to start developing these mathematical models and solutions to Air Force problems, but we want to take into account two things that are very important for us in the Air Force. The multiple domains, right? We're moving, first we had integrated domains, then multi-domain, now it's joint all domain. We want to account for space effects, land effects, sea effects, air effects, and so on. And so the proper mathematical abstraction will allow you to account for the multiple domains. That is where the heterogeneity comes from in the title of this topic. But then there's also the hierarchy aspect of it. If you look at the air domain, for example, you have wings that are composed of groups, that are composed of squadrons, that are composed of units. This is a hierarchy that has to be taken into account. For example, at the wing level, you might determine where the targets are. At the group level, you might determine which squadrons to assign to which targets. And then at the individual unit level, you have your decentralized execution. So these are all things that must be taken into account into the mathematical model that is derived and the mathematical solution for that problem. And we are not limiting prospective performers to a specific problem. As long as you can identify the heterogeneity, the hierarchical nature, and why it's relevant to the Air Force, then we're game. And I'll hand it back to Denise.
Thank you again, Dr. Velasquez. It's really great to have you as part of the team. You have some great background as well as some really awesome information. Finally, I'd like to welcome Dr. Sarah Bibick from AFRL to brief us on a topic of establishing common ground between humans and machines, which is STTR T002. Sarah, welcome, and looking forward to your summary on your topic.
Thank you, Denise. Good afternoon. Yes, I'm Dr. Sarah Bibick. I am a research psychologist in the Airmen Systems Directorate. I want to start by saying that this topic was a collaboration between AFOSR and the Airmen Systems Directorate, co-authored by Drs. Laura Steckman, Peter Friedland at AFOSR, and also Dr. Christopher Myers at Airmen Systems. So we know that for a team to successfully execute a task and communicate successfully during that task, it's not enough for the team members just to be able to speak and be able to understand each other. There's a lot of work that has to go into called maintaining, establishing, and repairing what's known as the common ground. And so common ground typically refers to the shared beliefs and knowledge that are relevant to a task. And because humans are so good and have multiple processes for maintaining and establishing common ground, this allows them to work in a very flexible way when they're accomplishing a task together. So for example, teams that work together over an extended period of time will adapt their language as they're talking. So they may entrain on specific kinds of language that allow them to be more efficient for the task, but they're also flexible. So they're able to change the way they talk if they encounter some kind of issue, or if there's some sort of miscommunication and they need to repair their representation of the common ground. They can change how they're talking in order to accommodate the miscommunication and get back to the task on hand. This is very difficult for AI systems to do. So currently we have systems that, for lack of a better term, they're more like tools than they are like teammates. So they're able to understand questions, they're able to pose questions, right? They might be able to ask you to repeat something if the system is aware that there's some sort of issue with what it may have heard. But they're not good at being able to flexibly adapt their language. They don't change their language over time as common ground is established, and they aren't able to then flexibly switch back when there's some sort of issue that arises and they need to institute a repair. And so the point of this topic is we are really interested in the development of systems that have these flexible and adaptive capabilities similar to humans. And we are really interested in machines that can participate more as a teammate in terms of maintaining and establishing common ground rather than just being a tool that you can direct. So a successfully completed phase 1 project should provide a literature review and also a feasibility study that demonstrates a path forward from a set of alternatives for the development of a prototype system that's going to be capable of maintaining common ground with humans while also completing a shared task. And one other thing I do want to mention is the part of what makes the establishment of common ground between humans and machines so difficult is that there's still a lot of work that needs to be done in terms of developing machines that are able to do full human natural language processing. This is in of itself a very difficult challenge. And so one component of this particular proposal that we are interested in as well is proposals that not only look at solutions to this issue within the realm of natural human language processing, but also in the realm of what are called controlled languages. So these are languages that are not quite as, they're not full unfettered human language, they're restricted in certain ways. And so in theory, they're easier to develop AI systems that are capable of interpreting these languages, but these systems should still be flexible to some extent. They should still should have demonstrated capabilities for maintaining, establishing, and repairing common ground, even if they're using a controlled language as opposed to unfettered natural language. So thank you for listening. I'm happy to take questions, and Denise, I will turn it back over to you.
Thanks, Dr. Bubba. Thank you so much for you guys co-hosting the actual topic that you guys did. AFOSR, Dr. Myers and team, Peter Friedland, all of you, thank you so much. So, and I want to thank once again to all of our speakers for joining us and taking the time to be here and brief us all on these very important topics around the subject of AI. So with that, all of our speakers have presented. We will now be shifting to the Q&A portion of this event. Please feel free again to write your questions in the Q&A panel. If you haven't already, we will have our presenters and technical leads answer for you live. Please be sure to include the name and number of the topic and submit to all panelists. These are some incredible, exciting topics that we have the pleasure of working with for this event. I'm thrilled now to open the floor up to our guest, Dr. Wysocki. Would you like to kick it off with a question?
Thank you, Denise. So in order to establish a common ground across these topics, I'll go ahead and start with the first question. We have a lot of questions coming in, and it's not likely that we will get to them all. So I guess, again, I'll reiterate that we will address these questions later in a frequently asked questions document and supply that on the website digitally. So for the first question, and this goes to transfer learning of control policies, SBIR D001. As part of my research, I want to evaluate my solution with human subjects. Do I have to go through an institutional review board? And so
Alvaro, that's yours.
I would assume so. I I don't deal with human subjects, but I think the answer is yes.
It actually is yes. So you do have to go through a review board in order for that to happen. So thanks for that, Alvaro, Dr. Wysocki.
all right, that was a short one.
Yeah.
So looking down through, and do we have some of the newer questions?
We do.
All right, so this is looks like a process-related question. What is the timeline from proposal submission to notification of invitation to the pitch day? Also, how many winners do you expect to award per topic? So we'll start with the first one, the proposal submission process.
Absolutely.
That's probably for you.
It is. So the timeline for proposal submission to notification invitation is we're hoping within a very short period of time, within a few weeks. So the time from closing to evaluation to selection notification, I'm going to say 2 to 3 weeks at the max. So how many winners do you expect to award per topic? So for each topic, we are looking at approximately, and again, this is an estimate, 2 to 3 awards for the direct to phase 2. And on the STTR topics, we're looking at the 10 per topic. So for phase 1s, so it'll be 10 STTR phase 1 awards and 2 to 3 per topic on the SBIR STTR award or more. It all depends on how things go. So thank you for that question.
All right, thank you. So now we'll move on here. And this question goes to SBIR topic D002, Assurance of Trusted AI and Machine Learning Systems. Is there a particular modeling formalism or language that is preferred?
So Steve, are you there? Well, he might be having some audio issues.
So I can try to talk on behalf of Steve there. So from my understanding, there's no particular model formalism that we're looking for. We're really leaving that up to the performers. These topics were specifically focused in this area, but left broad enough to really allow for a wide range of potential solutions. But my understanding is no, please feel free to use your modeling and formalism. All right. So I believe we've answered that question. If there's more detail requested, please just include that again in the chat. And I believe we'll probably try to address all the questions that we answered verbally.
Yes.
Also in the written frequently asked questions section, and so that people who are not in attendance today can also have access to this.
Absolutely.
Okay, this one is again for topic 1. So focus to Alvaro. Where do you think low resource learning comes into play?
So low resource.
And this is specifically addressed to surrogate environments potentially. So low resource learning. Again, thank you.
Right. I imagine low resource learning in the sense of what one might call sample efficient learning. We want to use very few samples to learn an effective decision-making policy. So in the surrogate environment, in a sense, we could be as inefficient as we want, okay, in the surrogate. In the target environment, we have to be very sample efficient. Again, this goes back to the data requirements that we're trying to mitigate. In the case of AlphaGo, 30 million games to reach superhuman performance, that would be prohibitive in the target environment, but it may be feasible in the surrogate environment. So you can be sample inefficient in the surrogate, but you must be sample efficient in the target.
Carl, appreciate that. We're just going through and looking at the questions just to make sure that we're all on the same page. So, you know, I think one of the things that I have a question on is, would the SBIR challenges be open to the STTR proposals? SBIR topics cannot be proposed against from an STTR company. SBIR is the small business. STTR is a small business with a nonprofit organization, institution in that. So hopefully I answered that question. If I didn't, please make sure that you maybe reiterate or explain a little further, and then I can take it from there. So thank you on that. So for D003, can a company submit multiple proposals on different application areas? So Captain Rudin, are you and your team available to answer that question?
I'd have to defer to on that. I mean, if the question is, can they submit against different topics, I don't see why we would preclude them from doing it.
Right. So just so you know, you can submit multiple proposals on the different applications as long as they meet those application areas. They cannot be the same proposal for every single area. So just please be aware of that. So, you know, make sure that, you know, we're following all the SBIR rules. Okay. So over to you, Dr. Wysocki.
Thanks, Denise. All right, we have one for Dr. Chris Myers. Have you seen how bias impacts this when a human suggestion or a machine suggestion is offered up simultaneously?
Yeah, I saw that. I'm not quite sure what this refers to. I guess perhaps it's trust or skill acquisition. I'm not quite sure, but I am aware that people act differently based on whether they're interacting with a machine or not. So in past research, we've had individuals come into the laboratory and conduct tests with synthetic teammates, and we're well aware that people interact with the synthetic teammate differently when they're told up front that they're going to be working with a synthetic teammate. And so I'm not quite sure that answers your question directly, but I am aware of bias and trust issues associated with knowing that they're working with an automated, autonomous, or synthetic teammate within a task. Thanks.
Yeah, thanks, Chris. That's actually interesting to think about as well. I don't know how I would behave if I didn't know whether it was a human or a synthetic teammate. I think I'd probably make that judgment, you know, subconsciously and have those biases as well. But thank you for that interesting question.
Yeah.
Do you want me to take another one?
Absolutely, go right ahead.
All right, so we have a question for Joseph Lyons. So as a psychologist, the individual's acknowledgement or intent versus subconscious intent, is that bias the projection of human perception of alignment? Do people know themselves enough to compare to a machine? So I can read that again if it was unclear. Joseph, I don't know if you have access to the text as well to see that directly, but I can read that again if you like.
Yeah, thanks, Dr. Wysocki. So I saw that in the Q&A chat. It's an interesting question. I'm not completely sure what they're asking, but let me try to respond in the sense that people know themselves well enough in order to make progress for this technical challenge. The key thing would be if the machine or agent is making an action in relation to a particular goal, the human is going to need the transparency methods to understand what goal, why that goal, what to expect on behalf of the agent in the future. So, to the extent that there's going to be conflicting goals, which is a real possibility, again, that human, whether it's a tester or an operator, is going to need to have that transparency for what's going on, why, what to expect on behalf of that agent. Over.
Awesome.
Copy that, thank you.
So I'm going to go back to Captain Rudin and his team, and I'm going to ask, does your topic include things like FFT or dynamically acquired targets of opportunity? So whoever on the team would like to take that, that would be great. Thank you.
So I would say if no one's going to respond, then the answer might just be no. They're not including that.
Copy, and we can also, if we're unprepared to answer at this time, we can look at providing more details, answers later on in a written format.
Right. So, Dr. Wysocki, I think I'm going to ask you this. So these are broad topics. What resources do we have to fine tune our projects? So what is it that these small businesses could do, or if there's even an opportunity for them to fine tune what it is that they're going to propose against containing the projects?
Okay, so yeah, let me take a crack at that. So, so these are in pre-release. This is the only time that we have to discuss any details or specifics or to improve or enhance any proposals that your company or university might have. With that being said, after this pre-release period, there really aren't any opportunities for additional discussion along those topics. Now, to comment on the focus of these, so recently, across the DoD and the Air Force, we're really pushing for innovation. And part of the way that AFWorks, the Air Force, the Cyber Center of Excellence, AFRL, and others are reaching out is really in a large pool to try to expand the pool of talent that learns to work effectively with the government and to tackle our problems. And there's a learning curve with that. So part of this is to expand the outreach. So with that, the Air Force has experienced with some very open topic calls so that we don't limit or stifle innovation, so that people can submit topics that they feel are very important to the Department of Defense. What we've done with this particular model is we've gone a little bit back to when we were much more formalized in the topic presentations. And I think these are more focused than what we perhaps have seen lately, but they're still broad enough. And the intent there is to allow performers to really try to understand where we're trying to go without limiting their solution set. So this is the time really over the next, I don't know when does when does the pre-release end and this becomes official, might be something to add to that. But I think it's an excellent question. And really the answer is these topics are released, and really that's the information that you have to go by.
Correct. So the actual open topic is May 17th. May 16th. Closing is June 17th. So you have that time frame to work your proposals. There is to be no discussions at that time with any government. You can post your questions to Citus if we, don't get to them, or you come up with a new one. So that would be great. So Citus is a site that you can use. We are also going to post all of these questions and answers on that site. And, we'll get back to you as soon as we possibly can. So I think Dr. Sarah Bibick for topic T008, would it be helpful to see how humans change in context of the group? Example is a builder may cuss when on the construction site, but speak more eloquently when speaking with his or her banker. Is it just semiotics and mimicking collective behavior, or is there an optimization in that common ground? If you need me to repeat that, that would be fine, Dr. Bibbick. But
That's okay, Denise. I think I have the gist of the question. So that's an interesting question. I'm going to say that it might depend. I mean, it might depend on the task environment. So we're really interested in these processes that help humans establish common ground so that they can accomplish a task better together. And so you might be able to imagine some situations where being able to, talk like one of the guys or something, or talk in a way that's appropriate for that particular group might be somehow beneficial to the accomplishment of that task. If that's demonstrable, then that is something that we would potentially be interested in. If it's purely adaptation for the sake of a social adaptation or a register adaptation that's not necessarily relevant towards accomplishing a particular task, I would say that's not the primary focus of this call. But if you can demonstrate that it somehow is going to benefit the team as a whole, that is something that we would potentially be interested in.
Awesome, Dr. Bibbick, really appreciate that. Thank you for that answer.
right.
Dr. Wysocki, you.
Hey, Denise, I have a question for you, I believe. It's described as a general question. So it says the BAA document says the Air Force will provide detailed information about the requirements and format for proposal. When and where should we expect to get those instructions? So that one's for you, Denise.
Thanks, Dr. Wysocki. So the interesting thing is there are a couple of changes that are being made on the BAA instructions as we speak, but they are listed in the actual instructions, and it says it's a 25-page proposal with a 15-page slide deck. So those are the two requirements for the proposal submission. The instructions will update. I know there was a question earlier, and I'll just kind of go through that quick too, where the 1 million versus the 1.5 million. We are only doing the 1 million. That is also going to be updated. It will not be 1.5. It is up to 1 million for the direct to phase 2s, 156.5 for the phase 1 STTRs. So hopefully that answers your questions. If not, you can go to the DoD SBIR site, and the instructions are actually listed there. There are 3 documents. Please make sure that you pay attention to the SBIR direct to phase 2 and phase 1. You'll find that the topics will say Trusted AI Pitch Day topics with the title. So those are the ones that you're gonna look at as far as the instructions go. So thanks, Dr. Wysocki.
No problem. So here's a more technical one addressed to D001, so Alvaro. There is some interesting research on sample efficient approaches that use side information like the laws of physics and symbolic knowledge. This is not directly related to transfer learning. Are such topics under scope?
As long as it is integrated within the transfer learning solution, sure. In particular, this is something that you could leverage, for example, in determining the similarity metrics between the surrogate and the target environment. If their dynamics models have some similarity based on the site information, this might tell you that you can transfer between the 2 environments. So yes, the site information can be leveraged both within the derivation of similarity metrics as well as the derivation of the transfer learning solution itself.
Thank you, Alvaro. So taking a look at the questions, so we have one for Captain Rudin. I'm not sure if, I think we can probably answer this here. It's not technical in nature, but I'll go ahead and read it. I'm interested in subsection 4, computer vision threat detection. And I have an AFWorks phase 1 STTR with MIT that's relevant. I assume it's okay to apply to this D2P2 separately, and that the STTR can take a different path for this problem. But any advice on how we can leverage the other STTR for this I think would be of value. So I hope I captured the essence of that question. Captain, you can take a shot at that. This might be one that we might have to look.
Yeah.
Denise can also supply supporting information. So if you'd like, we can handle it from here, or Captain Rudin, if you'd like to comment.
I don't really have any specific comment to add to that, except I believe you just can't apply for the directive phase 2 with your Waldo technology.
Correct. So Captain Rudin, you're very much correct on that. You cannot. Remember, so you can't do duplication of technology. We cannot have duplicative work. If you're doing it in an STTR, you cannot do it in a SBIR. So just be aware of that. You can leverage an STTR, so in the AFWorks process, a phase 1 is required to have an MOU or a letter of advocacy in the AFWorks open topic calls. And if you win it, that's in order for you to get a direct phase 2 or get a phase 2, I'm sorry. So in our world, in the AFRL part of it, you can't do a definite duplicative work. So if you're an STTR, you can apply for an SBIR if it's an SBIR. So just remember that. If I have to further explain that, we can do that. So otherwise, I hope that answered that question for you. And thanks, Captain Rudin, for that.
All right, Captain Rudin, you're a popular guy this afternoon. So this is a question, since your topic really has 5 areas of interest. Do proposals have to show competencies in all those areas, or is just one area of interest necessary for a proposal? So over to you, Captain.
Yes, sir. Thank you. So I think that was on purpose, that we wanted different areas. So I would fully expect you to have a proposal based on a specific emphasis area, not covering all 5. That would be tough.
Right.
All right, thank you, Captain. Denise, do you have any, or I've got some more coming in? We have some fresh ones as well.
Yep. So let's look at this one. If invited to the pitch day and we win an award, how long should it take to get under contract and start work? So I'm going to let you know that from the time of the decision, we have packages that'll be into contracting. It's 120 days after that. So we're doing it in July. I'm going to say November, just to make sure that we cover all of it. I know it's a little bit over 120 days, but November timeframe is really what we're looking at. So just so everybody knows. But if you are, it's 120 days.
All right, just a quick question. Do we have Steve Drager on the line? We lost comms a little bit back a while ago, just confirming.
Can you hear me?
Oh, there he is.
There we go.
So do you want to ask him the one that we...
All right.
So I have it from the beginning, which is right here.
Yep,
So
that's the one I was looking at. So
awesome.
go ahead.
Steve, what are your thoughts on continuous integration environments that involve re-engineering Devsecops?
So I guess I'd ask for a little bit more depth and detail as to what specifically is being asked.
Okay, so that's fine. So whoever asked that question, could you give a little bit more detail on that? Would really appreciate it. And then we'll absolutely have Steve revisit it. Dr. Wysocki?
All right, these are some really recent ones. We're trying to split them across topics and question proposers. I think this is a short one. And I believe it's focused on STTRs, but can proposals involve more than one institution?
So I'm going to take that, Dr. Wysocki. So we actually have had some past, look at whether this is true or not. So I'm going to suggest that you don't, not that you can't, you can, but there's a certain percentage that each of the institutions have to do while working the STTR. And the company obviously has to meet the requirement as well. So please make sure that if the percentage is what it is, I can get you the actual information and we can post it to that as well. But if you can, stay to one. If not, we definitely have to meet the requirements of the STTR policy. So back to you, Dr. Wysocki.
All right, now they're coming in quickly. So, so this is directed to topic D004. So explainable decision making. And the question is, are temporal logics for explanations under scope? Is it of interest in using restricted NLP for communicating the explanation?
This is not restricted to using NLP at all. NLP does not have to be used in any part of this unless you want to. Now, are temporal logics for explanations under scope? Absolutely. I think the use of temporal logic seems to be one of the most promising approaches for explainable AI. Things like, for example, linear temporal logic, computation tree logic, even non-temporal logics, even just first order logic. These are all very, very useful. And in fact, there is a paper you might be interested in, published in Europe's, I think 2018, where they derive a temporal logic explanation of a recurrent neural network for NLP. If you're interested in that, I can send you a link.
That would be great. Awesome. So just so everybody knows, so we looked it up and in the proposals involve more than one institution. So we got to make sure that it's 30%, that's a norm. But when it's more than one, there are certain requirements that we have to meet. So again, going to kind of give you a little bit more detail in that when we actually revisit this on the site. So you guys will know exactly what it is that you need. So thank you. Dr. Wysocki?
Yes, thank you, Denise. Give me 1 second to collect some questions.
Sure, absolutely. I can ask one if you'd like while you're thinking.
Go ahead,
Sure.
please.
So D005, what domains or tasks might be of interest, e.g. lab tasks, simple or complex gaming environments, high fidelity military simulations? If I need to revisit some of that, more than welcome to.
My response to that's in the chat or in the Q&A if anybody wants to go to it, but I can address it here just so everybody hears it as well. So the answer is, whatever you can use, whatever you have that's available to you that you can demonstrate progress within co-training. So if it's games, great. If it's a military test bed, great. That has great face validity and is of course sellable to the DoD. But anything, we really want these approaches and what we understand to be generalizable and useful across a set of different domains. And so whatever test bed you have that you're an expert in, that you can bring to bear on co-training, then I'm perfectly fine with that.
Awesome.
Thanks.
Thanks, Dr. Myers. Dr. Wysocki?
All right, well, there's a lot of Really interesting questions here. Okay, so this is a very subtle question. It relates to 007, and it's for Alvaro. Super cool. Is there cross applicability between this topic and the prior SBIR topics? Could you address an issue in one and then reduce it for a 007 application? So I think I follow the question. It's really looking at almost like cross capabilities amongst these topics. So if you want to take a shot at that.
Sure. I don't remember the numbers, but I'm assuming from the context of the question that 007 must be hierarchical planning. And okay, yeah, that makes perfect sense. Yes, if you can come up with a mathematical abstraction for the other topics that is amenable to a mathematically principled solution, i.e., not really a deep learning solution, perhaps more along the lines of good old-fashioned AI, which I've seen some questioners put up on the chat, then yes, there would absolutely be that cross-applicability across these topics. And it would be of interest to topic 007.
Awesome.
Thank you.
Yeah. So thanks, Alvaro. Really appreciate that. So other than you, Dr. Myers, because you already answered part of yours, does the scope include only bottom-up, non-symbolic ML techniques, not GOFAI, ML, hybrids, or other casual reasoners? So I'm going to start out with Alvaro. If you can answer that question first, and then I'm going to go down the line as to who we had in order. Thank you.
Yes, so this is what I was hinting at with my previous response. So actually, two of my three topics, you can apply good old-fashioned AI as well as causal reasoners to. In particular, the explainable decision-making topic, I think it would be a beautiful explanation if you could use something like a causal network, which I'm sure the questioner is familiar with. At any rate, I'm a big fan of Judea Pearl's work, which I'm sure you're also familiar with. There's a reason why he won a Turing Award. So if you can bring in any of that causality into the explanation, it would be very valuable, because it's a common misconception, right, that these deep learning systems are capturing some sort of causality. They're not. They capture correlation. That's not sufficient. So a causal explanation for the explainable decision-making topic, that would be great. And then for the hierarchical heterogeneous planning and scheduling, we are looking at mathematically principled approaches. So this is more along the lines of good old-fashioned AI, as current deep learning solutions are not particularly mathematically principled or mathematically interpretable. So those two topics are amenable to what the questioner suggests.
Awesome.
Can I add one thing? As probably the oldest fashioned AIer here at the discussion, I think that what Alvaro said is exactly right, and I think especially interesting from a research contribution point of view are systems that combine symbolic and neural methods to solve any of those problems. That's a very hot area in the field of AI as a whole right now, and would be a really interesting piece of work, at least from my point of view, to arise out of any of this. Do you agree, Alvaro?
I completely agree. The area of neurosymbolic AI is really blowing up. You know, this was an idea that is decades old, and then in the past 2 or 3 years, we're seeing all these big conferences sort of reviving neurosymbolic AI. I'm a big fan.
Peter, could you do me a favor and please introduce yourself? We've mentioned your name earlier, and I just want to make sure that you are recognized as part of.
Oh, sorry. My apologies. I've only been able to attend a little bit as I'm judging the International Science Fair and interviewing students right now. Too many parallel Zoom meetings. My name is Peter Friedland. I'm a computer scientist, been an AI person since 1970, so I'm very old-fashioned. And I've been an advisor to Air Force Office of Scientific Research and to other organizations like the Rome Lab for quite a while. So just very, very interested in seeing what innovative ideas result from these topics at both the university in the case of STTRs and commercial level. A lot of innovation can come from these programs in my experience. So we're really excited about seeing what comes out.
Awesome, Peter. Thank you so much for that, and really looking forward again to continuing the collaboration with you, AFWSR, and so on. Dr. Wysocki, I'm going to turn it over to you.
All right. Yeah, thanks, Peter, for your support again. It's great to have you. So I'm going to bring this question up again because I think it deserves the attention, and there's quite a few instances of it still appearing. So a previous question asked if a company can submit multiple proposals to a single topic. Can that please be readdressed? I'll take a crack at that.
Absolutely.
Although this is outside of my area, I think I've learned enough today. So yes, you can propose, or you can submit multiple topics or multiple proposals on a single topic, but they cannot be duplicative in their nature, right? So you can't try to sell the same technology to
each one.
Is there a better way to put that? Because if I was a business and I was looking at submitting something,
Sure.
I probably only have a few excellent technologies that I severely believe in, and I may be likely to say, well, I can certainly address this, and I can certainly address that. So I think let's readdress that you can submit to multiple broad topics, the 8 that we have.
As long as you're.
And what about submitting multiple times to a single topic?
So for instance, I'm going to use Captain Rudin's topic as an example. He has 5 areas. So within those 5 areas, there may be something that can connect into a different topic. The thing that I really want everybody to understand is if you propose to all 6 SBIR, right, as a SBIR company, and you win off that same proposal for 2 out of the 6 topics, that can't happen because the proposal has to show the difference in what the topics are. Now, Captain Rudin has 5 areas. You can propose to 1 area on that. That's fine. But just remember, if you propose to the other ones, that particular proposal has to have some different solution, different statement of work. There has to be a difference in the proposal you're submitting. You cannot submit the same proposal to every single one. You can submit to every topic, but just not the same proposal. So I think that's probably the easiest way to explain it. But when it comes to the STTR, it's the same thing. Just remember, you have to have a nonprofit organization. Did that, I think, explain it better? Or
I believe so.
Okay.
And I'm sure there are very process-oriented answers with specific references that we can include from
Sure.
contracting and others. That is why I try to stay technical and out of the business. So how are we on time?
we're great.
Okay, about 20 minutes left or so. Is that what we're looking at?
Yeah, 2025.
Okay, great. So here is one for topic 004. Explainable decisions. Could counterfactuals be considered as viable explanations for a decision? Or is this SBIR limited to explanations expressible in a formal language?
I mean, but both of these things apply. Reasoning over what happened as well as what did not happen. These are both conducive to generate an explanation. So counterfactuals are perfectly within scope for deriving an explanation. And so are formal logics. As I mentioned in a previous answer, things like linear temporal logic, computation tree logic, the mu calculus, right? We have all these very fancy logics. Those are all human interpretable and have very neat mathematical structures that one can leverage for an explanation. So yes, both of these are within scope.
All right, and while I've got you on the line, this one isn't addressed any particular challenge problem, but what is the scope of input material you are considering for decision agents? Would you include publicly available information? And what sort of situational awareness summary would apply here? So the first part of the question was decision agents or materials used to make that to include publicly available information. Is that?
I mean, I hadn't considered that, but I suppose. I don't know how to answer the first part of the question. I'm more interested in answering the technical questions, which the second part is more technical. Would some sort of situational awareness summary apply here? That is a form of explainable AI, but it seems to be lacking the decision-making aspect of it. So if you could derive situational awareness in the context of decision-making, which is to say, during the execution of a temporally extended tasks where you must take several actions, if you can come up with situational awareness summaries throughout that sequence, then yes, that would apply.
All right, thanks, Alvaro. And so I'll just make a comment on the first part. So you talk about publicly available information. So certainly in code generation or decision aids that affect operations or planning, the Air Force is certainly interested in taking in all available data types to combine publicly available information with exquisite classified information from sensor networks, and also that available through all of our intelligence connections and our data gathering and sensing modalities. So I would say, as far as the problem space, it's very important that we take these into account, but it is certainly not necessary, and we do not expect the performers to have access to some of that critical military data. So I would say publicly available information, if it makes sense for the problem that you're trying to solve, is fine, and even very important. But remember that the scope of a lot of this particular research is focused on developing the trust, the bidirectional trust between humans and machines, so that when we release these systems, that we can have some type of understanding of the probability of these systems doing things that we don't understand or are unplanned, and weigh that against the novelty and the utility of having systems that can act, learn, and respond to large amounts of data where the humans are basically useless. So, I think that's a great question, and certainly publicly available information is an important part of it. So I hope that somewhat answered your question. And that's all I've got for that. Denise, do you have anything
Bryant,
else?
can I add one thing to what you and Alvaro said very well?
Please.
I think one thing to keep in mind, which is very key to what Brian just said, is that improving one of the key things in decision making when people are dealing with intelligent systems is to trust what they do, to trust what they do in making a sometimes critical decision. The ability to understand why the intelligent system did what it did is really important. And as intelligent systems become opaque in their reasoning, being able to get some form of decent explanation capability, but whatever means, is really critical. So I think what Brian said, thinking about how the human element would use information to make a decision is sort of this interdisciplinary thinking about both the human and the machine when you're thinking about explanation during decision making. So it's not, the explanation should be, what I think would be key would be if the explanation helps a human being make a decision, either because it provides more information for the human to add information, or simply because it enhances human trust that the machine system made a decent, provided a decent piece of information in decision making.
Yeah, thank you, Peter. Excellent. So we have a lot of questions that are similar in nature. We're going through that list. But for a moment, I would just like to open up to the panel and the topic owners. You've seen the type of questions we have. You've probably reflected on the presentation that you've given. So I'd like to open it up just for a few minutes for a general discussion. Are there any particular topics or subtleties with your topic that you wish you would have addressed, or maybe you have an answer to some of the questions that we've already covered where you can provide additional background? So we'll give this a shot. If nobody responds, we'll start bringing up more questions. But I wanted to give the chance to have a great dialogue so that we can really talk about and try to get at the crux of these challenges in a way that's not always available through traditional questions and answers. So I open it up across the panel. Are there any specific comments that you'd like to make or discussions that are relevant to this topic? So open forum.
So this is Chris. So you mentioned things that I wish I had addressed and questions that I've already answered, and this kind of touches on both of them. So within my particular topic, there were 3 facets that I described. There were behavioral models, methods, and metrics. And I just want to be clear that proposals don't have to include solutions to all 3 of those facets, but could focus on any particular one of them in the context of co-training. Over.
Awesome. Awesome. Dr. Stuckman, are you on the line? Okay. So I think maybe, well, oh, Sarah, are you there? Is there
Yes.
anything you'd like to mention?
Yeah, since you asked about, similar to Chris, since you asked about things I wished I had mentioned, there was one thing that I wanted to just very quickly address. So when I was talking about common ground, right, I was talking about shared representation, shared knowledge. I wanted to just bring to everyone's attention also that for certain kinds of teaming tasks, it's also important to manage when people have divergent knowledge or complementary knowledge. And so in thinking about how your proposal might address these issues, managing those types of that knowledge is also important and something that we'd be really interested in considering for the proposal. So AI systems that are capable of tracking and processing that kind of information as well. Thank you.
Oh, absolutely. Thank you.
Yeah, and let's make sure we offer time for the other speakers. So we'll pause for a minute. If there's anything you'd like to bring up, please.
Yeah, so one thing that I'll mention real quick is that there's no, for the topic 006, there's no transparency model that's prescribed. You know, be creative, but justify what you do decide to propose against. There's no desired use case that we had in mind, but the use cases are really just examples to implement a transparency method, because this topic is really more about the human and their response to information. And the information comes in the form of those transparency methods, which can range from, again, experience that you get from thinking about maybe even like a training scenario, all the way up to an information display or a visualization. So that's the only thing I'll add. Over.
All right, thank you. So any other comments?
Yeah, Bryant, I think the summary of what Sarah and Joe and other people have said is could be simply stated as excite us with your proposals. You know, don't feel that you have to follow the exact wording of what you see in the writing. We're looking for ideas. Clearly, we're looking for ideas that capture what people said, but I think we're really interested in innovation. I think the I part is very important to us. So I think excite us, please, in the proposals.
Awesome. Captain Rutan, do you have anything from you or your team?
I don't have anything specifically to pile on. I just see there's a question in there about the multiple areas. Again, I would just reiterate, if you're submitting multiple proposals within my topic, they would have to be different technologies, different statements of work for each one. So keep that in mind. And then I'll pause for a moment to see if anyone on the panel from my team wants to add any clarifications to anything.
Your team's pretty quiet, Captain Rutan.
They must think
All
I'm
right.
doing a good enough job then, I guess.
That's right. You're doing great. Thank you so much.
All right, yes, thank you, Captain. So I think we have a few more minutes. I will pause one last time because I know what it's like to have something that you really want to say and you're looking for the opportunity. So again, is there anything particular from the group you'd like to mention? Otherwise, I'll try to squeeze in a couple more questions that came at the last minute. So back to the group and the open discussion. All right, hearing none, I will press on. So here is a question. I think it's for Denise. and it states, or it asks, does the direct to phase 2 requirement imply that the proposal needs to come up with a phase 1 solution, or does it imply that we have not participated in a prior effort and given acceptance that we meet these requirements of phase 1? Okay, so let me look at that again.
Mhm.
So do we have to also include, I believe is what it's asking, a phase 1 solution in the proposal, or does the eligibility for phase 2 imply otherwise? So I will leave you to try to answer that. I probably didn't express that very eloquently,
You're fine.
but I think you get the gist
I
of the
do.
question. So go ahead, Denise.
Absolutely. Thanks, Dr. Wysocki. So the one thing that with direct to phase 2s, you have to understand if you're already going to a direct to phase 2, you've already accomplished somewhat of what a phase 1 has done. Whether you're in a SBIR or whether you're not a STTR or not, whatever, the SBIR in general. So if you have already met those requirements in reference to the phase 1 as not a SBIR company, then you should be fine. You should be able to absolutely apply for the direct to phase 2. Because remember, direct to phase 2 is you're skipping all of the phase 1 parts because you're already there. You're already at that phase 2 level. So just remember that. You have already went through and done what you needed to do in the SBIR requirements for a phase 1 to go to that direct to phase 2. Hopefully that made sense.
I think so. And
yeah.
I was reading during your explanation, so I apologize.
No, you're fine.
But let me re-ask the question one more time
Sure.
in a very specific way.
Okay.
To qualify for phase 2, do I, as a company, ever have had to have a phase 1? No. Okay, copy that.
No, you have not. I mean, as long as you are a registered, company, SAMs, all the things that are required for a small business, you are able to apply to a SBIR as long as you meet the direct, needs requirements in that of what it is in a SBIR STTR world program.
Copy that. And I think we have time for perhaps one or two more. And this is associated with topics D001 and 004. What might be some specific examples of the system under scope? Does this include control theoretic systems, for example, F-16 flight control and navigation, or are these more oriented towards discrete time decision-making systems? So again, specific examples of systems under scope.
So I would prefer discrete decision-making systems, as these tend to capture the higher level objectives of command and control that we're very much interested in. Low-level control, as you typically see in control theory, is of course very exciting, but it's less applicable to high-level decision paradigms such as JADC2, Joint All-Domain Command and Control. So we're going to limit ourselves to that scope.
Awesome. Great. Thank you, Alvaro. So there are a couple of things that I want to cover quickly, if I may. So when I stated the percentage of the institutions and that for whatever reason, it should have at least 30% of the work for the STTR. The principal investigator, principal investigator can be from a research institute, RI partner, assuming that at least 40% of the work effort is being performed by the small business and at least 30% by the subcontractor, RI subcontractor. So if you're an established company, customers and commercial sales, and you have a product that can be useful for the warfighter, you may submit to a direct to phase 2 proposal. But again, we need to really look at that, whether there's dual institutions or if there's only one that's being performed. So just so everybody is aware of that as well. So thank you. Amber, thanks for that. I appreciate you looking that up for me.
All right. We'll address as many as we can, as quickly as we can. Topic 006, life cycle approaches to transparency. Is there a particular platform being considered for transition?
So no, the quick answer to that is no. Be creative, as Dr. Friedland talked about. Wow us.
All right, thank you.
So, I think at this time, Dr. Wysocki, I think we probably should just kind of go back and look at, all of the things. So, in your view, so I'm gonna kind of touch on your experience and your opportunities that you've had. What is it that you think the AI is going to do across the board for the ecosystem here and elsewhere, seeing that we're working a lot with the other folks?
Yeah.
So in the collaboration with them.
All right, so I'll do my best to address that. So I'll start with AI in general, right? We all know that there's a lot of hype around AI, but I think it's well deserved. And we're seeing AI, at least in military and DoD channels, in my opinion, progress past signature detection, classification, to include generation of COAs, the generation and the prediction of future outcomes, and some of the things I think we need and that this community can help identify is we not only need to recognize that these systems need to be reliable, robust, safe, but as systems become more generalizable, they'll be applicable across a large space. And I think in order to verify and validify and certify these type of systems, we need a digital engineering Air Force. We need, reliable and accurate models of our systems so that when we run simulations or we use data or we use, transfer learning, we have to make sure that our models, which much of this is going to be model based, they have to be rigorous and approved so that we have that continued faith in the decisions and so that we train our material or we train our systems on the correct material because they are just representations of their behaviors are representations of that data. So I think we have a lot of challenges in just getting the right data together, getting the right models, the simulation environments to allow not only AI to look at signatures and patterns and to make recommendations, but to be true partners in actions. I can see a time when artificial intelligence is actually overseeing the behavior of humans, recognizing irresponsible behavior, where AI would take control of a car or an air vehicle due to fatigue or cognitive, processing. And so the future is AI as a peer, AI as a decision maker, as a mission commander. And I think in order to do that and to prove that these systems are reliable and responsible, it's not only going to take these efforts in trust and trustworthiness and explainability, it's going to take the entire infrastructure. It's going to require an entire infrastructure of reliable data, models, and ways to exchange and have confidence in this. But we have to do it rapidly. So I'm really excited about what this ecosystem is going to bring, because these are challenging problems, not just from a science and technology perspective, but on a resource perspective, on a communications perspective, so that all these things are coordinated so that we can integrate them into systems that are so complex that humans can barely follow and understand the systems that we're designing. So I think this is just fantastic. I'm excited to be part of this. I'm just humbled to being in the presence of these awesome researchers and the companies that are going to contribute to this. I think we've put together some excellent challenge topics that have a balance of being broad but specific enough so that the submissions are focused on relevant and real Air Force research problems. So I can't tell you how much I'm looking forward to seeing the proposals and the pitches, and even more importantly, the rigorous and relevant research that's going to take place following on. And the question started out with the ecosystem. And I think this whole of nation approach that brings in basic research, developmental research, all the way through implementation, integration, and fielding is the infrastructure that we have to even begin talking about real solutions at scale. So that's all I really have to say about that. But again, I think you can kind of tell, I think it's just excellent to be part of this larger event. So back to you, Denise.
Awesome. Thanks, Dr. Wysocki. So I love the passion of all of the team that we have. And, you know, it's been just a great opportunity for all of us, whether it's in the SBIR program, small businesses, whether it's the scientists and all. So, okay, that's all the time we have for the questions. So any unaddressed questions will be answered and available on the CITA site, which can be located on the Air Force SBIR website as well. In addition, all registrants will receive an email that will provide a link to the recording of this AMA. We would like to personally thank everyone for your attendance today. Building this ecosystem is important, not just for the Air Force, but also for the small businesses and our nation's defense and continued evolution in greatness. Over to you, Dr. Wysocki.
All right, so thanks everyone for your attendance. It is our intent to continue this ecosystem thriving. We're looking at other types of events to support the growth and the nurturing of this type of teaming and partnership. And so I want to thank everyone for their attendance today, for the hard work that went into making this what I think is a great success. We look forward to some great proposals and associated pitches. So please join us for the main event in July, where we are working on a lineup of very interesting and influential speakers to talk about this subject in particular. And I guess we'll close. I'd like to bring up the slide that shows our partners that made this possible. And again, I think we'll just end on that slide. This was very interesting to me. I always learn in the presence of my colleagues. So on behalf of everyone on the team and AFRL specifically, thanks to the community, thanks for your attendance. We really look forward to what comes out of this. So this concludes our presentations and our proposals today. Have a great evening. Over.
Thanks, everyone. Have a great day.
Thank you.